Thank you so much for joining us. We will be talking about ultimate sashimi quality shrimp. Over the next 20 minutes or so, we will be talking about sashimi grade, handling and processing challenges, some ideal cooling and preservation techniques, deep chill process for shrimp, and then we'll look at the impact on the shrimp quality and operations. And in the end, we'll talk about the impact on your bottom line, because that's what matters at the end of the day. So sashimi grade. Sometimes people wonder, why would you eat seafood raw? Some people don't like it, but if you're like me, I always enjoy sashimi because it just brings up all that flavor, that sweetness that you want to have in shrimp, that crispy and bouncy texture. You want to really enjoy that. So that's why people are drawn into sashimi nowadays. And although there are some safety risks with consuming raw seafood, there are lots of guidelines for how to address parasites and bacteria and whatnot. That's not something we're going to cover today as part of this webinar, but what we'll be focusing on is the top quality of shrimp, because in the end, if your shrimp quality is not good enough for sashimi, there's no way you can change that with any controls, any techniques that you take in to for raw consumption. It's not going to change anything. So our focus is going to be that core product that you'll be producing. Now, when we talk about quality, what do we mean in the context of shrimps? So definitely the first thing that comes to mind, you don't want to see any black spots on shrimp. So any number of raised percentage of black spots is not acceptable for many buyers, actually. You look at the size, you want to have a complete body. You don't want to see any pieces broken and antennas or legs or anything missing. So you want to make sure that it all looks complete and whole. The firmness and the color are important. Depending on the species, you may want to see different colors like grayish green, some pinkish, and some light pink shells you want to see. And in terms of odor, obviously nobody likes the bad odor. It has to be mild. It has to be ocean-like kind of smell. Now, when we talk with a lot of our customers, when we first start the conversation, they have lots of challenges in the process. The first one is that shrimp is very sensitive. It deteriorates really, really fast. In the process, as soon as it's out of water, by minutes, it's like it's counting, right? Minute by minute, it's the quality is diminishing. And you want to have methods or techniques to control that. And this change is irreversible. So once gone, you can never take it back. The other challenge that sometimes we hear is because of this ice handling process, which is currently used in almost all shrimp processing facilities, it's always manual. There are people have to shovel ice and put it in boxes and layer them. And there is no way you can have a very consistent quality in that scenario. Temperature control from harvesting through processing up to freezing point, it's always a challenge. Usually shrimp farms, you talk about like warmer parts of the world, weather is already hot. It's very difficult to cool down effectively the product and maintain that temperature over time. Mechanical damages, another issue, especially when the handling is not done properly. There are difficulties there during ice handling, for example, or during transportation, during storage, there are always mechanical damages happen. And maintaining good hygiene, ensuring that no contamination is in the facility, or like cross-contamination from batch to batch and from different processes. So that's also another challenge that we hear about. Now, I touched on the cooling part because I think that's probably the most important part of ensuring a good top quality product is produced, is ensuring a temperature control is managed well. So why does that matter? Let's look at this graph. You can see here at the bottom the storage temperature, and on the other side you have the relative rate of spoilage. That means how fast the product can get spoiled over different temperatures. So as you can see, the colder that temperature, the lower that rate. If you're storing it at 4 degrees versus 0 degrees, you have almost a double the difference in the rate. So that's significant. And here's a study done that shows you that the temperature, storage temperature, if the difference from 1.5 degrees Celsius or 34 Fahrenheit, if you can instead drop that storage temperature to -1.5 or 29 degrees Fahrenheit, you can cut the bacteria growth by half. So that's significant when we're talking about shelf life and we talk about deterioration. You probably have like maybe 1 day in your facility that the whole process turnaround is, or 2 days sometimes. Sometimes we're talking about fishing vessels. The shrimp stays there unprocessed if it's not a freezing trawler, and it stays there for days. So you can see how that temperature difference can make a change in the quality of that shrimp. Another important factor is rapid cooling. The faster you can cool down the shrimp, the better quality that you can get. Like here, what you see is a very slow cooling process. Over a few hours it took to cool down a shrimp. And well, eventually it got down to like 1 degree over a few hours, but like by the 6th hour, they want to start processing it. So shrimp is out of the ice, it's going through the process, is grading and beheading and deveining, all that process, manual or machine. The shrimp is taking up the heat from the environment, the ambience. And this fluctuation, sometimes a few degrees, it raises up to 3, 4, 5. We've seen higher degrees even. And that's really, really not good for preserving that quality. You don't want to see, if you want to have a really top-notch quality shrimp, you cannot have this temperature variations throughout your process. So that will be causing all the black spot. That starts the degradation process and actually speeds it up. So with that introduction, we're now going to hear about Deepchill. So Kyle, back to you.
Thank you so much, Mina. And we often have people ask us about Deepchill all the time, like the same as ice and water, or what actually is it? What chemicals do you guys put in to generate the Deepchill? So that's what we are going to attack today. So what is Deepchill? Well, Deepchill is a slurry ice that comes in 3 different forms. So between 10 and 40% ice concentration by weight, it looks and feels a lot like a liquid, like water. Between 40 and 70%, it has that consistency of soft ice cream, and 100% snow is 100% snow. And one thing to remember is, for most of you, every piece of ice you've ever used in your life formed on a surface, whether that's flake ice, plate ice, shell ice, tube ice, that's all water freezing on something. What we do is completely different. So we're forming these crystals in suspension of water and making tiny, tiny ice crystals, maybe 0.1 or 0.2 of a millimeter in diameter. And because we form these crystals in suspension of water, if you look at them under a microscope, these crystals would be round spheres or orbs. And that uniform size and shape gives our resulting slurry a specific texture. And that's how we're able to suck the heat out of products just so much faster than ice and water or ice and salt water. And this is just comparing us to RSW systems, so chilled brine. And at the end of the day, even 25% deep chill contains more than 5 times the cooling power as chilled water. So again, this is just one of the ways that we suck that heat out of product, in this case, shrimp, so gosh darn fast. And with regards to shrimp, what's good about it is deep chill crystals, and deep chill itself fills all of those nooks and crannies between all of the shrimp. So one of the issues with shrimp harvesting and processing is you're layering shrimp. You're putting like ice and then shrimp and then more ice and then more shrimp. But the ice doesn't really make contact with a lot of the shrimp and it melts. So you get different temperature bands inside the same container where shrimp in the middle aren't the same temperature as the shrimp on the top or the bottom. So we solved that issue by giving you a consistent temperature throughout the tank or tote. And we also do it without causing any damage to the shrimp. So what I've seen from a number of harvesters is when they pack them into totes, it's actually that the shrimp on that middle layer that gets squeezed together. And that's where a lot of the damage happens. But that damage doesn't happen when you're using deep chill. And again, just completely night and day difference in terms of physical appearance. Shrimp and flake ice on the right are exposed to air and heat pockets, whereas the shrimp on the left are completely submerged in deep chill. So there's no chance of air being able to do damage to the shell or to the antennae. And that's because we're flowing all around the shrimp and filling all of that dead space between them. This is a great cooling curve right here. This was done by the Marine Institute at Memorial University, and they were testing the difference between chilling shrimp the conventional way with ice, with flake ice, and using deep chill. So on the left, you see where they use 25 pounds of shrimp, 44 pounds of ice. So that's a greater than 1-to-1 ratio of ice to shrimp. And it took somewhere in that 6 or 7 hour range to get close to 0 degrees Celsius. Whereas in deep chill, we actually use less ice. So 25% of 75 pounds is like 18.5, 19 pounds of ice. So we use less than half the ice and we're able to achieve much better results. So within 3 to 5 minutes, we're able to crash the shrimp temperature from about 15 Celsius to 0 and pull it below 0, which is something that you're not able to do in ice. And we actually had to put these on 2 completely different charts. Because if we had included the deep chill cooling next to the flake ice cooling, it would just look like a straight line going all the way down. We are orders of magnitude faster than chilling with flake ice. And when we talk about coldness, well, really what we're talking about is the cold chain. You know, from the point of harvest to the point when you're shipping them out of the facility, it's important to keep the shrimp either sub-zero or at 0 degrees Celsius, because those enzymes just turn the shrimp into mush. So if you can harvest those shrimp into deep chill and maintain less than 0 degrees Celsius, and then transport them at less than 0 degrees Celsius, and then when you receive them at the factory, they're already below 0, and we've maintained that quality prior to processing, you're gonna have a better end product. Especially when you sort, you're going to sort better shrimp because again, negative temperature range. And then you're either doing a raw process line or cook and chill and then to the freezer. And that's one thing that people don't think about is freezer capacity. So the colder the shrimp are as they go through your freezer is the more shrimp that you can process with the same freezer equipment. But delivering results is the most important thing. That's what we were saying before. Either a project has a return or it doesn't. And these are some of the success stories that we've had both in our own backyard and beyond. So in Canada, we're able to take this wild shrimp product and not only extend the fishing trip by 2 days due to better temperature control, but also give people a much higher quality product. And in New Caledonia, just off of the coast of Australia, is some of the most expensive shrimp in the world. The Japanese call them tenshi no ibi, shrimp from heaven. And these shrimp are somewhere in the $120 to $150 per kilogram range. So like $60 to $75 a pound. Beautiful blue shrimp. And these shrimp are processed in deep chill just because of how expensive the product is. And we've gone from a low volume, high quality to a much higher volume harvester and processor. So this is the Nakwa shrimp project just off the coast of Saudi Arabia, where they farm 250 square kilometers of shrimp farm. And we were able to triple their delivery of grade A shrimp to their various markets. We're able to increase that freezer throughput by 20% because the shrimp are much colder as they go through processing. They were able to repurpose or eliminate numerous positions just handling ice. And out of all the facilities I've been to, shrimp is one of the most intense in terms of ice consumption. So just think for a moment, that small army of people that you have whose sole existence in life is just to transport, maintain, and shovel ice. So we replace all of that with a person with a hose or with a downspout of a hose. And this also mitigates contamination. Many times it isn't the ice that's contaminated, it's the shovel that's shoveling the ice that's contaminated, or the tote that the ice is in that's contaminated. So we remove all of these touch points. And this is just some of the pictures from the Saudi Arabia project, from the Nakwa project. So we have some large storage containers here, and then we see the trucks going out to collect the shrimp from the boats, the shrimp inside totes here. And our equipment is not massive. One of the interesting things about Deepchill is you can put our equipment in some machine room at the other end of the facility, and then we just pump Deepchill to wherever you need it, in this case on the exterior of the building. But we offer a significant number of advantages for any operation, especially shrimp producers and others. So we're giving you the perfect temperature control and a continuous cold chain. We're able to improve the operational efficiency through automation, as I was saying before, repurpose or eliminate those positions, and extend that processing window without compromising quality. And when visiting processors, it's that bottleneck that causes them the most amount of grief when they receive 100,000 pounds of shrimp from a boat. Now they have to store it and then process it, and improve the hygienic handling and better HACCP compliance because there are less touch points, there are less people and less operations touching those shrimp. But again, at the end of the day, a project either generates a return on the investment or it's not worth doing. So the number of ways that we contribute to ROI is by increasing production yield, reducing labor, virtually eliminating product degradation, and potentially for the harvesters, extending those fishing trips due to the utilization of Deepchill. And we have some ROI examples here. So if you're a processor and you're processing 50,000 pounds at a time, and the wholesale value is $5 a pound, the value lost for 13 weeks due to cold chain issues, or 1% of the volume, is somewhere in that $160,000 range. And if you're a harvester and you're out there in the middle of the Atlantic, Pacific or somewhere, and your trip length can't be more than 5 days because the shrimp just turn into muck after that, we may be able to extend your fishing trip by an additional 2 days, have you fill that hold or bring in 23,000 more pounds, have a higher catch value, save money on time and fuel, and at the end of the day, deliver a premium product that you may be able to get a premium dollar for, In our experience, the shrimp harvesters who are using Deepchill, the boat owners who have Deepchill as part of their boats, are getting an additional 5 or 10% premium for their product because it is a number of days fresher. Colder, fresher, faster, longer. That is all we do here at Deepchill Technologies or Solutions. We get your shrimp colder, faster, they stay fresher longer.